Hi, I'm Matt Romanko with the Ohio State University Extension. So what is a phosphorus filter? How does it work and where should they be used? Well, I'm at a farm in Northwest Ohio to give you a first-hand look at a phosphorus filter and talk a little bit about this relatively new best management practice that some farmers are using to reduce phosphorus loading to their watershed. So come on, let's take a look.
Phosphorus is an essential nutrient in agricultural production. Without a sufficient supply of available phosphorus, plant growth and crop yields can be diminished. On the other hand, excessive soil phosphorus levels have the potential to increase nutrient loadings to watersheds and contribute to water quality issues such as microcystin toxicity and hypoxia related to harmful algal blooms. When we think of the total amount of phosphorus that exists in our surface waters, we can break it down into two forms that are important to consider individually. Total particulate phosphorus, or TPP, which is the portion of mineral phosphorus and phosphorus ions weakly attached to sediment particles being transported in the water, and dissolved reactive phosphorus, or DRP, which is the portion of phosphorus that is dissolved in the water. Of the total amount of phosphorus that exists in our surface waters, 100% of DRP is considered bioavailable to algae, whereas only around 8% of TPP is considered bioavailable. Phosphorus trends in the western Lake Erie Basin have shown a steady decrease in TPP since the 1980s, thanks to increased agricultural conservation practices focused on reducing erosion. However, these same practices have proven insufficient for dealing with DRP, as we have seen a resurgence in DRP loading starting in the late 90s to early 2000s. In order to effectively address phosphorus loading from agriculture, we need to consider new management practices that focus on reducing DRP.
So what is a phosphorus filter and how does it work? A phosphorus filter is a system that is designed specifically to remove DRP from surface or tile runoff. It works by capturing DRP in a filter media that has a high affinity for phosphorus ions.
These media are referred to as phosphorus sorption materials, or PSMs. Some examples of different types of PSMs include steel slag, fly ash, metal turnings, and manufactured PSMs.
There are several ways to design phosphorus filters depending on the site-specific needs. This is an example of a phosphorus filter that was created using a septic tank as the primary structure. Here we have approximately 20 acres of farmland that drains into a tile main that runs into the phosphorus filter. Inside, the water is dispersed through the plumbing so that it flows through the PSM, which removes the DRP before releasing it out into the watershed.
This system is using a manufactured aluminum-coated iron oxide PSM that is very effective at removing DRP. Phosphorus filters may also be designed to work in a variety of other types of settings as long as the system is designed following four basic principles. 1. The filter contains a PSM with a high affinity for phosphorus ions. 2. The filter is placed in a hydrologically active area with high concentrations of dissolved phosphorus. 3. The structure is designed to ensure high dissolved phosphorus water is able to flow through the filter and have enough contact time with the PSM to effectively remove dissolved phosphorus during maximum flow events. This principle is very important because around 90% of phosphorus loss occurs in less than 5% of flow events, which are the largest flow events. 4. The PSM can be removed and replaced once it's no longer effective. Alternatively, some PSMs can be recharged by chemically stripping the phosphorus ions from the filter media. This phosphorus-rich solution can then be treated to precipitate solid phosphorus fertilizer that can be reused on the farm. Some examples of different types of phosphorus filters include surface confined bed filters, blind inlets, ditch filters, or specially designed filters for treating runoff from things like CAFOs, silage bunkers, or other areas that contain high concentrations of dissolved phosphorus.
So where are P filters appropriate and how would you go about designing one? Well, unfortunately, the P filter is not a silver bullet that can address 100% of DRP loading from agriculture. When considering the cost of designing and installing a P filter, the most cost-effective locations to utilize this technology are areas where high legacy soil phosphorus tests supply high concentrations of DRP runoff that can be captured and channeled through the filter system. Phosphorus filters need to be designed to meet site-specific requirements that vary from location to location. Some of the things that are considered when designing a phosphorus filter are peak flow rate the filter must be designed to handle at a given location, hydraulic conductivity of the PSM, concentrations of DRP in the runoff, phosphorus removal goals, and the life expectancy of the filter. Some other important things to consider when designing a phosphorus filter system are that phosphorus filters should not be used to filter out particulates. There are more efficient methods to filter out particulates before the runoff reaches the P filter. Particulates can plug the filter and reduce the lifespan dramatically. Furthermore, PSM should always be evaluated for safety to reduce the possibility of unintended environmental concerns. Cost share opportunities may be available for individuals interested in installing a phosphorus filter on their own land. For more information, contact the Ohio State University Extension.